As we all know, our Earth does not move randomly or alone through the universe, but is an integral part of a superordinate constellation, which in our case we call the solar system, the eponymous host. Star serves the 8 planets and their moons, but also the dwarf planets, other small bodies like comets, asteroids, and meteoroids, as well as the totality of all gas and dust particles as a central fixed point to which all these entities are gravitationally bound. A look over the walls of the Galactic Baseball Stadium shows that the cosmic variety of such systems is significantly larger than many would assume at first glance. In fact, our home solar system is only one of many possible compositions of gravitationally bound celestial bodies. Just how manifold these cosmic assemblies can be in reality was reinforced by terrestrial experts when they identified some time ago an unusual star system, one that puts everything so far known to shame. What unexpected constellation the astronomers stumbled upon, and what different star systems we have been able to discover in the universe so far, you'll find out in today's video. Do you get excited about the groundbreaking discoveries and spectacles in the universe? Then remember to subscribe to our channel and click the bell for regular updates on these compelling topics. By giving us a thumbs up, you're showing us that we can keep you engaged with the content of our videos. A cosmic quartet, as we mentioned at the beginning. Our home solar system is characterized by the influence of a single massive celestial body. The fact that such glaringly bright formations come together gravitationally sometimes in the form of a double star system has been known in the ranks of experts for a long time indeed. The existence of so-called quadruple star systems composed of 2 separate double star pairs has been proven in the past. The fact that the corresponding star constellations are surrounded by an enormous ring of gas and dust, a so-called protoplanetary disk, is also part of basic astronomical knowledge. To understand the characteristics of such a multiple constellation, it's worth taking a look at the star system HD 9800, which is located about 146 light-years away from our blue home planet. And indeed, for a long time, it seemed as if the corresponding collection of celestial bodies would show the common properties of known quadruple star systems. However, a detailed study of the surrounding protoplanetary disk provided the insight that HD 9800 is one of the most unusual formations that experts have discovered in the recent past. In detail, the system consists of an outer and an inner pair of double stars. The inner pair, which has been named BABB, is separated by a distance roughly equal to the distance between the Earth and the Sun. The 2 outer stars, named an AB, are much further apart in detail. The galactic gap that prevails between the 2 celestial bodies is quantified to 54 astronomical units, or AU for short, to explain. 1 AU corresponds to the approximate average distance between our terrestrial home and the Sun, or approximately 90 million miles. In other words, the outer pair of stars is much farther apart than the Sun and remote Pluto. The distance between the former member of our planetary system and its host star is only 40 AU. So while the gigantic distance that prevails between the 2 outer stars already leaves us open-mouthed, it becomes all the more interesting when we take a closer look at their more interior counterparts, or the protoplanetary disk that surrounds them, an unusual alignment. Typically, a protoplanetary disk is always on a plane that corresponds to the orbital plane of its 2 stellar hosts. However, as scientists now realize, this commonly used scheme cannot be applied to the case of HD 9800, because in fact, the protoplanetary disk here is practically perpendicular to the plane of the inner pair of stars within the scientific community. Such a constellation is called a polar configuration. In simple terms, this means that the disk does not run in an east-west direction, but rather in a north-south direction. To visualize this fact, we can imagine the inner pair of stars like a horse carousel at a fair rotating around a common horizontal center. The outer protoplanetary disk, however, would have the rotating characteristics of a Ferris wheel in this metaphor, before the unusual properties of HD 9800 could be proven conclusively. Such cosmic systems existed only in theory. How profound the discovery is in the overall galactic context becomes clear to us when we keep in mind that protoplanetary disks are where planets are born. Given this background knowledge, then it's not surprising that after their groundbreaking discovery, Experts were immediately eager to find out whether planets could also form in those disks that have such an unorthodox orientation. The fascinating research results, despite this strange configuration, valid features were detected in HD 9800 that clearly point to an early phase of planet formation. How the further development of the celestial bodies will take shape in the future, however, is still literally written in the stars, so experts cannot predict at present to what extent the planets can form permanently within such a seemingly chaotic system, and ultimately stabilize at all. So, although there are still many mysteries to be unraveled regarding this fascinating constellation, leading astronomers are already certain that we will find many more such cases in the future. Finding fully formed planets in these systems could be another significant astronomical finding. Thus, the next task for scientists will be to identify the corresponding systems at different phases of their evolution. Binary stars. It's advisable to examine the intriguing binary star systems more broadly in light of this amazing discovery. Because the bright celestial bodies are gravitationally bound to one another, they form a physical unit that rotates together around a common center of gravity. At first glance, one might assume that the gravitational merger of two stars is an extremely rare occurrence, but in reality, the corresponding celestial bodies are frequently so close to one another that they appear to us from our terrestrial point of view as just a single star. According to current estimations, the realities are actually quite the reverse. 70 of the Milky Way stars belong to a superordinate binary system. Within the category of double stars, this galaxy collection would be referred to as a multiple star system if one or more additional stars joined. Experts distinguish between several kinds of the situation above described. When the celestial bodies orbit a similar center of gravity and are gravitationally coupled by their spatial proximity, is known as a physical binary star. In contrast, optical binary stars are simply galactic fallacies. According to this, some stars that are visible from Earth appear to be in nearly the same direction in the sky, but in reality, they are so far apart that they do not gravitationally influence one another. Lastly, the geometric binary stars complete the cosmic squadron of star pairs. These are celestial bodies that are relatively close to one another, but they are not bound by their high relative velocities, whereas physical binary stars rotate steadily around a common center of gravity. The encounter of geometric binary stars and their planets is a unique event. While pairs of stars very close to each other sometimes take only a few hours to complete their orbit, in more extreme cases, it takes several millennia. Those celestial bodies orbiting each other at a greater distance interact with each other only slightly. But if the distance between the stars is so small that the so-called Roche limit is exceeded, a mass transfer between the radiating bodies frequently occurs in some constellations. Typically, physical binary stars are made up of a brighter main component and a fainter companion. The orbital periods that prevail within this system vary greatly depending on the distance between the stars. Binary star systems can also contain planets. These exoplanets assigned to the S-type draw their orbits around only one representative of the pair of stars, and because the corresponding planets are either too far away from them or too low in mass, they are essentially not influenced at all by their counterpart. The situation is different for the P-type planets, which orbit the double star system from far outside as if there were only one star. These exoplanets are known as circumbinary planets. It can occur that within a binary star system, there are zones for both S and P types, and the exoplanets can coexist despite their different planetary orbits. The intriguing thing is that some of these celestial bodies are regarded as red-hot candidates when it comes to the theoretical existence of extraterrestrial life forms. Basically, experts come to the startling realization that binary stars are accompanied by exoplanets about as frequently as single stars are. What do you think about the fascinating double star systems and the extraordinary protoplanetary disk in HD 9800? In the recent past, more and more exoplanets have been identified in binary systems. Even Alpha Centauri, the closest binary star to Earth, is home to multiple planets, according to our current knowledge. Finally, feel free to view the other fascinating films on our channel by clicking on one of the images in the credits. Thank you for your interest, and we hope to see you again soon. Please leave your comments with your views, ideas, and suggestions regarding today's topic.